Okay, today we're going to take a look at solution Stoic. So the first thing we're going to do is we're going to balance a nice reaction involving sodium hydroxide, which is obviously aqueous. We're going to combine it with HCl, which is also aqueous. And if you recall from Science 10, the addition of these two will produce a salt and water. So here's our salt, NaCl. And that's also totally soluble. And of course water, which you can either write as HOH or H2O. You need to put a little L there. Now the other thing you need to do is make sure it's all balanced out first. So it's a 1 to 1 to 1, everything's balanced. Step 2, we're gonna now do a little Stoic with this handy dandy little reaction. And I'm gonna make up some data for you. Let's assume that I'm gonna be using 500 mils of this. And I want to figure out how much of this is gonna take to neutralize this. There are two pieces of information that you need to know. You need to know the concentration of both of them. So let's make those numbers up. Let's say this one is 0.050 moles per liter. That's the standard unit for concentration. And over here we have, let's do a nice easy one, 0.02 moles per liter. Okay, so that's all the information given in the question. We're actually trying to find out how many liters of HCl it'll take to completely neutralize 0.5. Notice how I just quickly did that conversion. And you can write the 00 if it makes you happy, or you just worry about the zeros at the very end when you're dealing with the significant digit issue. So this is now liters, and it's liters of NaOH. So this is just a statement of the actual problem. We're trying to find how many liters of HCl will it take to completely neutralize 0.5 liters of NaOH, given the fact that the concentrations are not the same. First thing we're going to do is convert my liters of NaOH to moles. Liter and liter will cancel. Liter must be at the bottom so that can happen. We have a concentration already given in the question. Look up NaOH, it's right there. So you write 0.05 moles and 1. Second step is to ultimately convert the moles of NaOH into moles of what I want, which is HCl. So we're going to have moles of NaOH at the bottom so that we can cancel them. And we need moles of what we want up at the top, HCl. This and this will then cancel. This and this will cancel. And I have not even worried about the coefficients yet. But where do I get those coefficients from? You go back to your balanced chemical equation and you'll notice that it's a 1 to 1. There we go. Last but not least, we're in moles of HCl. We want liters of HCl. So there must be something in this question that gives us a relationship between moles and liters for hydrochloric acid. And there it is, my friends. We now need to convert this moles of HCl into liters of HCl. Now notice I'm writing HCl again twice. You could avoid that part if you like, because HCl is already written up here. But quite honestly, if you look at the concentration, the 0.02 must go next to the moles. So this time it's down in the bottom. And 1 will go up at the top. Now in terms of cancellation, mole and mole will go, that HCl and that HCl will go. And notice what I have left is exactly what I want. So the last part of this is just the calculation part, which basically you should be able to do. I'm not even going to bother finishing it. Just take that number, multiply it by this, avoid this, and then hit the divide button, and then 0.02, and then you'll have an answer. You can put the answer there. What are the units? Liters of HCl, AQ. And you are going to need to worry about sig digs at this particular point. And it looks to me, let's do something. We'll put a 0 there. And now we are entitled to only keep 2 sig digs in here. Hope you enjoyed my first attempt at a little video lesson on solution stoichiometry. This is actually a very specific type of solution stoichiometry involving an acid-base neutralization. Have a wonderful day.